Take our pink. Okay, so that was that. What comes here is going to be, let's draw the molecule first. One, two, three, 4 carbons. Enough over here to see. One, two, 3, 4. It's going to get that weird ketone O here that I could have drawn it different, but I didn't. Methyl here, so there's 1, 2, 3. Those 2 are done. Color them in because we're getting ahead of ourselves. Sitting on a green crayon. Oxygen first. It's ketone. Ketone's a double bond to a carbon when it's in the middle somewhere. If it's on the outside, it's an aldehyde. In this case, it's a ketone. I'm going to look ahead and I'm going to see a CH2, another carboxylic acid out there. Let's just finish this off quick. We've been spending a lot of time doing little baby steps, okay? We're well-weathered chemists now. There's the O. It's going to get a H in there. That's just a hydrocarbon. So 1, 2. Buckle my shoe. It's acetic acid. Kind of sounds like a stutter, doesn't it? Aceto. Aceto's 2. Ace. Think of an ace. In this case, is 2. Usually an ace is 1, isn't it? So aceto is at 2, and then an acetic acid is that part. Aceto. Change the spelling. Higher case, lower case. Because, boy, when they're together all lowercase, I can't even read them. Acetic acid. Acetic acid. So you get this. This would probably be number 1, 2, 3, 4. See, they don't tell you, I guess there is no other place for that to be a ketone unless it's there. If it's here, it'd be an aldehyde. If it was next to that, it'd be somewhere it wouldn't form. It'd be kind of like an ester kind of thing. No, it wouldn't either. So the ketone's got to be there so they don't number it. But that is acetoacetic acid. Throw in some capital letters to stress how you're going to pronounce that thing if you have to. Okay, so color them in if you want. So this is a ketone, but I don't think this is the end product yet. So again, like I said, I could prepare this and professionally do it, but I want you guys to see the way I go through it the first time and see the mistakes I make and learn from them. And the other product you'll get will be acetyl, what do they got here? Acetyl-CoA off to the side. So acetyl is just a diamond. S. So here's our star to CoA. And that's a ketone. Acetyl-CoA. The acetyl part of that is going to be a ketone, so we better figure a better way of drawing that. And a methyl, we're not afraid of that, right? 1, 2, 3. So that comes off. This is what we're focusing on now. If NAD comes into the picture, Say NADH. NADH with a proton. What that's going to provide is 2 full hydrogen atoms. So we're going to put those onto here somewhere. Where do you think they're going to go? 1, 2, 3, 4. We're back to a 4-carbon molecule here. So there's 1, 2, 3, 4. See a carboxylic acid on the end. This is simple double bonded O, single bonded O. I see an alcohol here. So alcohol's got proton. So what did that do? It went to the ketone, brought an H to a ketone. Now you got an alcohol. You still got the carboxylic acid out there. So one step at a time. Color in the oxygens here. Alcohol, carboxylic acid. That carbon's done. Color it in. Bring our H's. There's a methyl group on the end. No biggie. 1, 2, 3. This is a straight carbon. All right, now to name that, beta hydroxy. Check it out, big long name, huh? Good thing I didn't name this. Beta is 2, so it's 2 from one side or the other. We don't know yet. Beta hydroxy, which could be another name for 2. Depending, they're obviously coming from here. So, well, beta's 2 over, so 1, 2 on the second one over. Beta hydroxy, butyric. Butyr stands for the 4 carbons. Butyric. R-I-C. Butyric acid. Boy, big long name for that, huh? You see why eventually they'll start giving them little acronyms? BHBA? I don't know. But this is a beta hydroxy butyric acid. So all it means is the hydroxy is a beta OA, carboxylic acid, butyr is 4, butane, So you count across this way. 1, 2, 3, 4. That's the name beauty. I'm trying to find if you can pronounce that with beauty in it. It's butyric. It's a beauty, huh? Butyric acid. Now another way that this can go is to acetone, okay? Acetone's wicked stuff on the body. That's why if you're not having a good nutritional day, you get ketone bodies in your urine. Well, what that's showing is things aren't getting broken down the right way. So acetone in your bladder is not a good thing, more or less in your liver or in your bloodstream. So acetone, do we remember what acetone is?